morning, student. Today we'll discuss about the compression processes in the compressor. Now, we already have some idea about the compressor regarding compressor, reciprocating compressor like this, single stage compressor, double stage compressor, single acting, double acting compressors. So basically in the compressor, compression process takes place, and the compression process that can be in isentropic compression, that can be polytropic compression, that can be isothermal compressions. You already have some idea that isentropic compression, isentropic process is such process, thermodynamic process, where the entropy is constant, S is constant. Okay. In case of polytropic process, it follows the Pv to the power n is equal to constant. And isothermal process, the temperature is constant. Okay, we already have some idea about the basic engineering thermodynamics. From that point of view, we can idea about that in isentropic compression process takes place is isentropic, means reversible adiabatic process, and in that process entropy will be constant. Now, and in case of isentropic process, the maximum available energy is in the gas is obtained. Okay, the question will become in your semester that which compression process is very much effective in the compressors. So the answer will be obviously isothermal process, isothermal compression process. Okay, why we can discuss later. Now, as we know that the polytropic compression means Pv to the power n is equal to constant, and we know that suppose this is the Pv diagram of a compressor or compression process. In that process, it shows that main three process, suppose 1 to 2, 2 to 3, and 3 to 4. So 1 to 2, 2 to 3, 3 to 4. So 1 to 2 is your suction in the compressor. 2 to 3 basically compression process that takes place, that can be isentropic compression, that can be polytropic, that can be isothermal compressions. Now, you have to choose that which one is suitable for your compressors. Okay, but that can be any either of three. Now, suppose if you draw the PV diagram of a process where it indicates that process 1 to 2 or 2 to 2 like that, 1 to 2, 2 to 3, 3 to 4. So 2 to 3, if it is happened so that this can be three different process, like suppose this is your 3, so 3 dash, 3 double dash. Okay, now 3 dash is basically indicate this is a isentropic compression, isentropic compression process. Now 2 to 3 dash is actually a polytropic compression process, so that means Pv to the power n is equal to constant. Now 2 to 3 double dash, it suggests that this compression process is basically isothermal compression. So from the previous idea, from the previous knowledge of the thermodynamics, we know that so work done is nothing but area under the curve of PV diagram. So area under the curve in process 2 to 3 double dash is actually small compared to the low, actually compared to the small compared to the other three processes. So we actually choose the isothermal compression process because the work done required for the compression process is small. So power required for the compression process in case of isothermal compression is very much less. Okay, so you can choose, identify the PP diagram of different compression processes like that. Now, the second topic will be your what is the power required. It is already given to you in your study material, so go through it. And now next topic, power required for driving the compressor. Okay, so power required for the driving the compressor, that means what is the power required for driving the compressor? So if the compression process isentropic, it can be polytropic, it can be isothermal. So depending on the different conditions, depending on the different compression process, the power requirement is very different from process to process. Now you have to calculate what amount of power required for different three processes. Now first of all, when you calculate, so some following assumptions are there. So first assumption is that when you calculate the power required, so first assumption is that no pressure drop, no pressure drop, no pressure drop is first point. Second point, no pressure drop through suction and delivery valves. Okay, number 2 point, complete compression process takes place in one cylinder. And there are so many other points or other assumptions also out there, like no clearance volume in the compression cylinder, and working fluid behaves as a perfect gas, and there is most important, there is a no frictional losses. Okay, these are the assumptions part. Now when you calculate the power requirement of different compression processes, first we calculate the compression process. If suppose the compression process, if you isentropic process, now for that isentropic process, when you calculate what amount of power required for that, if the compression process follows the isentropic compression, so that means isentropic process is basically PVT over gamma is equal to constant, you know that. So gamma is your basically adiabatic polytropic index, sorry, specific heat ratio. So that is nothing but Cp by Cv. And now if you calculate the work done required for the isentropic compression process, the work done during the compression process 1 to 2. Okay, now the total working process will be suppose isentropic compression. If you draw another diagram, it suggests that so 1 to 2 is your suction, 2 to 3 is your compression, 2 to 3 is your compression, 3 to 4 your discharge, and 4 to 1 return in its original positions. So now compression process 2 to 3 actually takes place in isentropic process. Now the total work done in this process means the area under the curve 1 2 3 4 1. Okay, that means work done during the process 1 to 2 plus work done during 2 to 3 and work done during 3 to 4. Okay.